Hello everyone, welcome to IMS GATE Academy. I hope you are enjoying our foundation series that we have started yesterday with the theory of machine subject, right? And in the yesterday's lecture, I've started with the introduction part of the theory of machine, where we have discussed about what is theories of machine is all about, what it actually consists of, what are the parts that we need to understand, okay, before going into details of theory of machine part. So some basic introduction we have taken in the last lecture, right, where we have talked about what is machine and how that machine is different from mechanism, okay, and we have seen so many mechanism also. So complete idea we have taken about the mechanism in the last lecture. Now we will go into details of the mechanism, okay, how the mechanism works. What is the basic building block of any mechanism? All those things, details, small minute details also we will cover in the lecture. Okay, so in today's lecture we will start with the kinematic link and with the kinematic joint. Hi, very good evening, mechanical world, very good evening. Okay, so in this lecture kinematic link and joint we are going to discuss. Okay, now very important part, guys. As I already told you in the last lecture also, theory of machine is again very interesting topic if you learn it from the basic fundamentals. Okay, if those fundamentals are clear, then this subject will be the most interesting subject in the mechanical engineering, and it will also become scoring if all those basics are clear. You will be able to solve all those problems that will come in your GATE examination, right? So that's why first of all few sessions will be mostly theoretical. Most of the part we will be discussing about the theoretical part, right? Very good evening, Pratik. So you need to understand, without knowing those theoretical part we can't solve any numerical, because in the theory of machine there are so many mechanisms, there are so many machine elements. Without knowing how actually they are performing motion, we can't really understand the analysis part. So we need to first understand the motion part, then only we can do analysis of forces. That is what required. Very good evening, Matan. Right. So let's start the session here, guys. But before that, please join this Telegram group. Okay. In this particular Telegram channel, you will be getting all the YouTube lectures that we are conducting. Complete schedule you will be getting. Apart from that, all the job notifications and daily quizzes that will help you in your examination. Okay. And apart from that, some sessions we are going to conduct there. All those information will be available in this particular Telegram channel. So I will suggest everyone please join this channel, and the link is also given in the description box, and directly you can visit this website also to directly join this Telegram channel. Right. Now let's get started here. So if I just basically discuss the few things that we have discussed in the last lecture in theory of machine is, first of all we have talked about the machine part and we have talked about the theoretical thing, theory part. So machine is what it will transform the energy into some useful mechanical work, right? And what is the theory part here? The mechanics, the engineering mechanics that we have discussed in our engineering part, engineering first year. So that concepts of mechanics will get utilized here to understand the functions, how the machine is performing different functions. That basic theoretical knowledge of engineering mechanics you should be having. Then you will understand how that particular machine is performing different functions, how the motion is happening between different elements, different links, different components of the machine. So to understand all those motions, some basic concepts of mechanics is what required. And we have discussed about like what is mechanics, statics part, dynamics part. First we are going to do the kinematic analysis, then we are going to do the kinetic analysis. And also we have discussed why the first kinematics we have to discuss, not kinetics. What is the logic behind that? The logic behind studying first kinematics is what? We will first do the motion analysis. Right? When I say motion analysis, you should understand motion will be there because of the change in position. Because of change in position. And then correspondingly you will be having displacement, then velocity and then acceleration. These parameters is what related to the motion part. We are not concerned like why that motion happened, because of what factor that motion has occurred. We just focusing on the motion part. Once we have done that analysis, then we'll come about come to force analysis. Because in order to calculate force, first you need to do the analysis of motion only. That's why first kinematic analysis, then comes to the kinetic analysis. Right, so all those basics we have discussed, and we have also talked about what? Mechanism part. And what was the basic difference between mechanism and machine we have discussed? Anyone tell me, what was the basic difference I have discussed with you in the last lecture regarding mechanism? I told you this point that mechanism and machine differ with respect to its purpose. In mechanism, we will be talking about the motion. Basically, mechanism is a device which is going to transform the input motion into output motion, which is what desired pattern of motion. We are only concerned about the transformation of input motion to output motion. I am not concerned about the forces, power or the work related to that motion. I am only concerned about the motion. I have given some input motion, I got some output motion, and that output motion should be a desired pattern of motion, whatever you have desired. Okay. So we are only concerned about the motion in case of mechanism. Although it may transmit power or forces, definitely, but we are not concerned with that. So that's why I told you the basic difference between machine and mechanism is what? With its purpose. The basic difference is the purpose. Purpose of mechanism is different, purpose of machine is totally different. Okay. So these are the basic fundamental things you should be knowing, right? So, and I've told you also the definition part, mechanism we have discussed, right? So all these 3 points we have discussed in the last lecture, okay? So differs from a mechanism in its purpose or the objective, I can say. Purpose or the objective of machine and mechanism is different. Although it can transmit power and forces, no doubt about that. But the point is, main predominant idea is of achieving the desired pattern of motion. That is what the main idea behind the mechanism. Got it? So that was the complete discussion we have in the yesterday's lecture. Right? Now coming to the next part, guys. Kinematic link. Now we are going into details or small things in the mechanism itself. So to have a clear understanding how the mechanism will be developed, what is the basic elements in the mechanism, okay, all those things we are going to discuss in this particular lecture. Right? Now coming back to this term kinematic link. Kinematic link in general term, I can say it is a basic building block of mechanism. Basic building block of mechanism. It means there will be number of kinematic links which are connected, okay, which are connected in such a manner that it will transmit the motion. As I told you, mechanism is what? Device which will transform the motion, na? So there are so many parts in that particular mechanism. So each part will be called as kinematic link. So it is a basic building block of mechanism. Different links will get connected, and when one motion is given to any one link, that motion will transfer to another link with which it is get connected. So this is what very important part, right? So the definition of kinematic link, please understand, guys. It is a part of a machine, right? It is a part of a machine which is having a relative motion with respect to another part, right? So maybe it have 3 member, 4 member, 5 member, 6 member, number of members it can have, number of parts it can have in a mechanism. Each individual part is known as kinematic link. But whenever I will say kinematic link, you need to understand a very important point, that is what? It should have a relative motion with respect to another part. It should have a relative motion with respect to another part. So let's suppose 2 bodies don't have any relative motion between them, then both are considered as the same body only. And this is a very important point. Later on we will be discussing this point in more detail when we discuss complete mechanism also. But here itself we should understand mechanism. In mechanism we have a kinematic link. So what is kinematic link? It is a building block of mechanism. So different kinematic links will get connected together, and the complete system will be called as mechanism. What is required in that kinematic link? What is the basic function of this kinematic link? To have a relative motion. to have a relative motion. That is a very important point here. So basically you should underline this term, relative motion, right? This relative motion you should underline here. Okay. Now coming back to the next point in this kinematic link itself. The next point is link should have two important characteristics. First, relative motion, as I already told you. Second is what? Resistant body. It should be a resistant body. Now what is resistant body? You might have discussed about the rigid body. There is a small difference between rigid body and a resistant body, right? But I'm not saying it has to be a rigid body. Kinematic link need not to have what? The rigid body, but it must be actually a resistant body. There is no requirement that kinematic link should be a rigid body, right? But it should be, or I should say it must be a resistant body. If it is not a resistant body, then it is not able to perform its function. What is the function that kinematic link has to perform? Transmit the motion. Transmit the motion. Again, understand this very, very important point. In mechanism, purpose of mechanism is what? To transform the motion, and the different members which are get connected together to form a mechanism, and that any one member is not able to transmit the motion. Any one member which is not able to transmit the motion, then how the transformation of motion will happen? Are you able to understand this point? If any one member of the mechanism is not able to transmit the motion, then how the transformation of motion will happen in that particular mechanism? Not possible, right? So that's why relative motion and resistant body. Now what is resistant body? Resistant bodies are those bodies which are capable of transmitting the motion, without getting deformation, without getting deformed. Deformation will be there, but that deformation within the permissible limit. If I said without any deformation, then it becomes a rigid body. There will be some deformation allowed, but within the permissible limit. Clear? So kinematic link in general sense, you should always remember, it is a building block of a mechanism. It should have a relative motion with respect to another parts, right? And it should be acting as a resistant body. And why I'm saying relative motion it should be having with another part? If it is not having that relative motion, then definitely it is not going to behave as a kinematic link. And I will give you the example also. Right, now coming to this point, resistant body. So you should note it down, the definition of this resistant body also. Body which is capable of transmitting the required forces with the negligible or the deformation within the limits, with negligible deformation. Or if the deformation is happening, that deformation should be within the permissible limits, right? So that is what the resistant body we are having, right? Okay, I hope this point is clear. Now coming back to the very important note point regarding the kinematic link. The very first point is kinematic link need not necessarily to be a rigid body, but it must be a resistant body. This is very important point, right? Okay, so this point you should remember. Need not necessarily to be a rigid body. I'm not saying it has to be what a rigid body, but it should be a resistant body. What do you mean by resistant body? It should be capable of transmitting the required forces or the motion with negligible deformation. Now, next point. Kinematic link is a resistant body, or it can be an assembly of resistant body. Either any one body can be there, any one resistant body can be there, or assembly of different resistant bodies, right? Let's suppose this is what one body. Either it can be assembly of three different bodies like this. So it is also considered as a single link. It is also considered as a single link. Both are considered as a single link. That is what the meaning of the second point. So in this particular case, three different members are get connected to form a single link, right? So that is what the second point is telling here. Okay, so please note it down, these 2 points in your notebook. Kinematic link is a resistant body, or the assembly of resistant bodies connected in such a way that they form a single part. This is very important point. Connected in such a way that they form a single part of it having no relative motion between them. Because if they itself having a relative motion, then all will be considered as a different link. Right? So as I told you, this is one particular link. Right? Fine. Same link I will be using 3 different links. This kind of 3 different links I will use, and I will join them like this. So when I have joined all 3 links, okay, this is one single link. Similar to that link, I have taken total 3 links similar to this link, and I have joined like this. Now when I have joined like this, now they will not have any relative motion between them. And this is, remember, this is a fixed joint. Okay, this is a fixed joint, not a turning pair or any kind of motion will happen here. It is a fixed joint. So all 3 are get connected in such a way that they will not have any relative motion. They are get connected in such a way that they will not have any relative motion. It means it is completely acting as a single link. It is completely acting as a single link. This is also single link. This is also single link. So, but this is what? This is the assembly of resistant bodies. This is a single resistant body. And this is an example of assembly of different resistant bodies we have. Either one body will be there or assembly of resistant bodies can be there. So assembly of resistant body example is this one. I hope this point is clear. Okay. Later on, this basic meaning is what required. This basic understanding of kinematic link is required while calculating the degree of freedom. While calculating the degree of freedom, this basic understanding of link is what required. Without knowing this much basics, definitely you are going to do some mistakes in the calculation of degree of freedom. Right? Okay. Okay, so please parallelly you should note it down all these important points, right? Now coming to the next part, classification of link. We can have rigid link, we can have flexible link, we can have a fluid link. Okay, these are the 3 basic classification of the link. One by one we will discuss the different examples. We will see the example also, the rigid link, flexible link, and specifically this fluid link. I've seen many times many students are confused how the fluid is acting as a link, and I will show you one animation also. Then you will easily understand, because the main purpose of a link is to what? It should transmit the motion. It should transmit the forces. It should transmit the forces and the motion. That is the basic purpose of any link. If it is performing that function, then definitely it is acting as a link. Right? Now, as I told you, rigid, flexible and fluid link. First of all, rigid. Obviously, rigid it is there, so definitely no deformation will be happening there. Example, crank, connecting rod, piston, like that. Okay. So this is what the example of rigid link. Remember, rigid means no deformation at all, right? Does not undergo any deformation while transmitting the motion. That is what the rigid link. Deformation is there. Deformation is there. Very important point. But within the permissible limit. But within the permissible limit. That is what example if I talk about belt, chain, right? So deformation is there, but within permissible limit while transmitting the motion. Okay. That is there. Now, third example, fluid link. Third example is fluid link. And example I have given here, hydraulic press. Third classification is fluid link. Example is what? Hydraulic press. Now, I will show you some animation here. Now, please understand this. This animation. In fluid mechanics, lot of time you have discussed them. Also in your school physics also. In school physics chapter also you have discussed this kind of example. So what happens here? I am applying some kind of force here, and that here also I am getting some amount of force. I am applying force here and also I am getting some amount of force here. How is it possible? Because of that fluid. So fluid is able to transmit the force, or it is able to transmit the motion, I can say. Because of the fluid. See, between this piston and this piston, the connecting link is what? Fluid. Fluid is able to transmit that force, na? I have applied an input here. That is what my input, right? That is my input given. Here I am giving the input and here I am getting the output. Are you getting the point? Here I am giving the input and there I am getting output. Who is responsible for that? This fluid. So that's why this fluid is also considered as a kinematic link. So in general, we have rigid link, flexible, fluid. Rigid, no deformation at all. In flexible, there will be some deformation, but within permissible limits. Example, belt and chain, and finally fluid. For that, I have shown you the example also. Fine, clear till this point, everyone. What is kinematic link? Kinematic link, basic building block of a mechanism. It is basic smallest part of a mechanism, right? Different links will get connected and it will form a mechanism. How the mechanism will work, what kind of motion we are getting from that mechanism, that we will discuss later. First of all, we have to discuss about a basic part, basic building block. That is kinematic link we have to talk about here first. Okay, now there is one more classification. There is one more classification. That classification will be based on number of ends. There is one classification we have done like rigid, flexible and fluid. Now another classification we have done based on the number of ends. Like see, first of all binary link. Okay, I will show you here what binary link will be there. Binary link means, let's suppose a link which is having two ends, that is what known as binary link. Ternary link, a link which is having, okay, please understand this point, very important point. Binary link, two ends. Ternary link, three ends. This is the link which is having three ends. And remember, this is a ternary link. This is a single link, not three links. Many people will confuse 1, 2, 3. They will say, sir, three links. Arey, why it is three link? I am telling it is a ternary link. And always remember, whenever you draw any ternary link, please draw these lines so that no one will get confused here. This is a single link. Don't count it like this 1, 2, 3 and 3 links. No, it is a ternary link. It is a ternary link which is having three ends. Binary link is having two ends. Clear? Binary link, ternary link, three ends. And similarly, we have a quaternary link also. Let me draw the quaternary link also here. So link having four ends. Okay, I will show you some practical example also here. Okay, don't worry. You will get all the clarity here. I will show you some practical example also. So binary, ternary, quaternary. How we have decided? Based on number of ends. 2 ends, 3 ends, 4 ends, like that. Okay. Four ends like this. Clear? Done? Now, see some of the practical example I will tell you here. So let's suppose this is a kind of a link we are having in the machine. Now for that kind of link we are having, I will draw a line diagram, or you can say kinematic representation of the member. Kinematic representation of the member. How we will do that? See, like this, simple. Kinematic representation of this member will be done like this, or I can say line diagram I have drawn here. Is it clear? Now, second example. Okay, second example. For that, the line diagram will be drawn like this. For this one, the line diagram will be drawn like this. Is it clear? So these are the practical examples, right? For that, how the kinematic representation has been done like this. So you have to understand. In the numericals, in the quotients, directly they will give like this, and you will be confused, sir, what actually this member is representing. What is the meaning of this diagram? So you should understand there will be definitely some member will be there. For that, the kinematic or the line diagram has been drawn. So for example, for this diagram, you can understand this is a actual example, actual case. For that, we have drawn the kinematic representation or the line diagram. This is the actual case. This is also actual case. For that, kinematic representation or the line diagrams. So many times I've seen people are confused, sir, why this line they have drawn, what this line is representing, what this triangle is representing. So many things, so many confusions. Because directly, if you see in some of the textbook also, they will draw like this only. And you will always in a confusion, ki sir, what this line is representing. Now coming back to some more examples. Now let's suppose this is a part of any machine. Let's suppose this is a part of any machine. How I will draw the kinematic representation? How I will draw the kinematic representation or the line diagram? See, like this. So please understand, in the textbooks, in the questions, while studying also, many times we are directly drawing this diagram, but in back of your mind, you should have this image also. Are you getting my point? In back of your mind, you should have this image also. So whenever I am drawing this kind of link, you should have a clear picture in your mind. Okay, there will be some kind of element in my machine for which I have drawn this kind of kinematic representation I have done. Okay. Next, this one. How I will draw this one? Like this. Simple. Here, this point is representing. Okay, this is what the rotation. At this point, the rotation will happen. Now, this is what a turning pair. Actually, later on in this lecture only, I will tell you about turning joint also. Okay, but let me write it here itself first. Turning joint. Two different links are get connected here. Link number 1, link number 2, and they are connected with a turning joint. This is what a kind of turning joint. Turning joint means where the rotation can be possible, where rotation happens. So this is turning joint. Another name of turning joint is hinge joint, pin joint, or revolute joint. Right? So turning joint means it is a connection between two different links. Two different links are get connected here, and what kind of connection it is having? Where the rotation happens. So that's why the name is called turning joint. Is it clear? So these are what the kinematic representations, and this is what the actual diagram we are having in our machines. So these are actual machine parts. For that machine parts, we are drawing their kinematic diagrams. So in your mind, it should be clear, whenever we are drawing these diagrams, it is nothing but the kinematic representation of actual machine parts. Done? Like this. These are the machine parts for that kinematic representation. Right? This one, kinematic representation. Actual machine part, kinematic representation. Actual machine part, kinematic representation. Right? Now, coming back to the kinematic joint. Just now I have given you one example also. Joint means what? When there is a connection. What do you mean by joint? Connection, basically. Okay, very basic definition is what? The connection between the links. Is it clear? Connection between the links. So these link 1, link 2. So basically this is my link 1. Okay, this is my link 1. And this is link 2. Both the links are get connected. How they are connected? By the turning joint. Turning joint means where rotation happens. Like this. Now, so please write down the definition as well. Okay, please make a note of all those important definition, guys. Parallelly, you should take a notebook and write all important definition. Because each and every definition and the point that I am mentioning here will be utilized, okay, will be used basically when I will solve numericals, for example, degree of freedom numericals. At the time of the solving, at the time when we are solving degree of freedom numericals, at the time all this theoretical knowledge will be required. Without that, you can't solve any degree of freedom question. I'm telling you this point. And when we are solving degree of freedom question, I will ask each and everything, that whatever part we have discussed, what is kinematic joint, what is kinematic link, what kind of kinematic links we have discussed, classification of kinematic link, all those basic points that we have discussed in the lecture will be used or will be required in order to solve any problem with regards to degree of freedom questions. Degree of freedom questions are very important with respect to GATE examination and also for your university examinations. So that's why the theoretical part that we are discussing has more important weightage. And I have seen whenever we are discussing a theoretical kind of thing, many students will get bored. Actually, this is most interesting part. Why you are not able to understand any mechanism or the machine part? Because the fundamentals are not clear. Because what is mechanism? Nobody knows. What is kinematic link? What is kinematic joint? Different types of link and the joints. If those basic knowledge if you don't have, then how you will understand the functioning of any particular machine element? You will not able to understand the functioning of the machine. How that links are get connected. Why that only this kind of motion is happening. So lot of confusion, lot of doubts you will face if you don't know the exact basic foundation of the subject here. Is that clear, everyone? Okay, fine. Now, as I told you, in kinematic joint, it is simply a connection between the kinematic links which have a relative motion with respect to each other. Again and again I am telling you, this is very important point. This relative motion, if the relative motion is not there between different links, if the relative motion is not there between different links, you can't call those two different link, okay, as a two. Actually they are not different links, they are actually a single link only if the relative motion is not there. For example, this is a turning joint, this is link 1, link 2. So obviously rotation is going to happen, 1 can rotate about 2 or 2 can rotate about 1, fine. But let's suppose both 1 and 2 are connected in such a way that this is what the fixed joint and the angle between them is theta. If it is the joint is fixed, theta is also fixed. But in this case, theta is variable. It will vary. In this case, I cannot say link 1 and 2 as a different link. Both will be considered as a single link only. Reason? Because they don't have a relative motion with respect to each other. They don't have relative motion with respect to each other. That's why they cannot be called as a two different link. Yes, in this case they can be called as two different link. Why? Because rotation is possible here because of this turning joint. Rotation has possible, so 1 can rotate about 2 or 2 can rotate about 1. Relative motion is there. That's why two different link, link 1, link 2. But here link 1 and link 2 is not possible. This is a completely one link. A link which is like this. So this is single link. Why it is single link? Because there is no relative motion. No relative motion, same link. Okay. And I am discussing in so much detail because while solving question in degree of freedom also I will ask you this question. Because in calculation of degree of freedom, first of all you need to calculate number of links. And many times I have seen students are doing mistake in calculation of the number of links also. In calculation of the number of links also you are doing the basic mistakes. Because the definition is not clear. Definition of kinematic link is not clear. Definition of kinematic joint is not clear. Right? So that's why this much basics is what necessary here. Okay. Done. Now coming back to the classification. First of all we have done the classification of kinematic link. Now we will talk about classification of kinematic joint. Okay, there is a difference between kinematic link and kinematic joint, right? Very basic difference. There is one link when two different links or more than two different links are get connected, it will form a joint. Either two link can form a joint, three link, four link, or any n number of links get connected, a joint will be formed. Clear? So connection between different link is known as joint, but there should be a relative motion. If relative motion is not there, then there is no meaning to call that connection as a joint. Okay, that it means it is not itself a connection. Please remember, the relative motion should be there. Without relative motion, you can't say that it is a connection. Now, classification. First of all, the classification will be based on the number of links which are connected. As I told you, either two links, three links, four links, like that. So based on the number of links connected, we will have a different kinematic joint. We will have different kinematic joints. Okay, first, binary joint. So let me just draw the diagram for you here first of all. Okay. Link 1, link 2. Two links are connected here, binary joint. Binary joint short form will be BJ. Binary joint. Two links are connected here, binary joint. Simple fundamental thing. Okay, any two link will be there. Okay, any two kinematic links are connected, known as the kinematic joint will be known as the binary joint. So that joint will be called as binary because two links are connected. Next, ternary. So here what will happen? Three links will get connected. Link 1, link 2, link 3, like this. So ternary joint. Ternary joint short form will be TJ, like this. Now one fundamental thing that you should understand here regarding the ternary joint. In ternary joint, can I write 1 and 2 as a binary joint, 2 and 3 as a binary joint, and 1 and 3 as a binary joint? Yes, obviously I can write now. For this moment, let's suppose this is a ternary joint. For a moment, ignore the 3, link number 3. Ignore the link number 3, you will see 1 and 2 as a binary joint. Now, ignore link number 2, consider 1 and 3. So binary joint will be 1 and 3, right? Ignore link 1. Consider 2 and 3, it is a binary joint. So in total, how many binary joints I can write? I can write, see, 1, 2 as a binary joint, 2, 3 binary joint, and 1, 3. 1, 3 as a binary joint I can write. Right, this is 1, 3. Now, total 1, 2, 2, 3 and 1, 3. Total 3 binary joints. Fine. Now, if I ask you how many minimum binary joints will be required in order to completely define the ternary joint? 3, 2 or 1? Tell me, what will be your answer? Again, I am repeating the question. Out of 3, how many minimum number of binary joints will be required so that we can have a clear understanding of this ternary joint? Answer will be what? Any 2 binary joints. Any 2 binary joints will be required. So in total I can write basically here this one ternary joint, one TJ is equivalent to 2 binary joint. Is equal to 2 binary joint. Okay, one ternary joint equals to 2 binary joint. Clear? Now the question is, sir, how is it possible? See, please understand. If I take 1 and 2 and 2, 3, if I take 1 and 2, If I take 1 and 2, 1 and 2 will be like this, and then 2, this is 1, 2, and then 2 and 3 I have to take. So I will get the complete ternary joint, na? For example, like 2 and 3, I have taken 2 and 3, then I have taken 1 and 3. Again, complete ternary joint I will get. So if any of the two binary joints I will take from the ternary joint, I will get complete clarity of the ternary joint itself. So because of that, I can write ternary joint is equivalent to 2 binary joints. So never ever write equivalent to 3 binary joint, because minimum 2 binary joints are required only to define the ternary joint. Is it clear? Okay, fine. Now, right, now coming to this point next, quaternary joint, very important. So link 1, link 2, link 3, and this is link 4. So the joint or the connection has been formed where total 4 links are connected. Total 4 links are connected here. So quaternary joint. So basically it is what? The quaternary joint, right? Now again the short form here will be QJ. Now again in this quaternary joint, how many binary joints I can write? See, 1, 2, 1, 3, 1, 4. Then I can write 2, 3, 2, 4. Then I can write 3, 4 like this. Clear? Total this much binary joints I can write. But out of this, how many minimum binary joints will be required? How many minimum binary joints will be required so that I will have a clear idea of complete quaternary joint? So that I will be having the complete idea of this quaternary joint. Tell me, how many binary, minimum number of binary joints will be required? What would be the correct answer? 3. Any of the 3 you can take, any of the 3, right? So one quaternary joint, okay, one quaternary joint is equivalent to 3 binary joint. One quaternary joint is equivalent to 3 binary joint, and this information is very very important while doing the numerical of degree of freedom. I am repeating again and again all of those important details. That is what required in upcoming lectures where we are going to solve the degree of freedom problems. That's why I am stressing so much on this particular things, right? So based on the number of links connected, kinematic joint can be classified as a binary joint, ternary joint, and quaternary joint. In ternary joint, it is equivalent to 2 binary, and quaternary joint is equivalent to 3 binary joint. Clear? This information is very very important. Now, on the basis of nature of contact, next classification, please make a note of all these things, right? Everyone, in this foundation series, please make complete notes, and this notes will be very much helpful in all of the technical examination, whether it is GATE or engineering services or AE examination or any public service or PSU written examination. In all the examination, these important things will be coming. Okay, so that's why first we are discussing some theoretical things, and then later on we are going to solve some numericals, some questions also from previous year examinations, like from the GATE examination we will take, from engineering services also we will take. Okay, but for that, first of all, some basic foundation we have to make now first. So that's why lecture 1, 2, 3 and 4 will be totally based on building the foundation for this particular theory of machine subject. Fine. Nature of contact. Nature of contact can be surface contact or the point contact. Either the contact will be point or the surface contact, and point contact as well as line contact we will say. But first of all, surface contact. Example of surface contact like this. Link 2, link 1, link 1, link 2 are connected. Obviously, what kind of joint it is? I've already told you this example. Ternary joint. Okay, ternary joint. So here you will see the surface contact is there. Here you will observe there is a surface contact. Clear? One more example if you take. This sliding is happening. So this is what the surface contact. So this is link number 2 and this is what the link number 1. So there is what the surface contact is there. So whenever a surface contact is there, okay, whenever there is a surface contact, right, it is also called as a lower pair. Later on I will write also. Okay, you have heard about this term also, kinematic pair. We are discussing kinematic joint and there is a term in the books, if you see, it is written as kinematic pair also. Pair usually we will write when there are two links. Okay, usually when there are two links we will write kinematic pair. So when it is having a surface contact we will call it as a lower pair. Okay, done. So surface contact, because here surface contact is there, surface contact is there. Example number 1. Okay, regarding the nature, okay, because the second classification is based on nature of contact. First classification is surface contact. Second classification we will be having the point or the line contact. Example, cam and roller. So this is what the point contact. This is what point contact, and it is also known as higher pair. Whenever point and line contact is there, it is called as higher pair. So let me write it here itself. Higher pair when there is a point or line contact. Whenever there is a point or line contact, and here it is called as lower pair. Whenever there is a surface contact. Lower pair, surface contact. Clear? Okay. Now next classification. Next classification is based on the relative motion. First classification based on number of links connected. Second classification based on the nature of contact. And the third classification is based on relative motion. Okay, total 3 classification we have. This is the last classification based on relative motion. So first example, as I told you, turning, pin joint, hinge joint or the revolute joint. All 4 names you should know. Okay, don't be confused what is revolute, what is pin joint. Either I can call it as turning joint, pin joint, hinge joint or the revolute joint. All 4 names should be clear to everyone. Right? Examples. Right? This is one of the example. Now coming to the next one, sliding joint and the prismatic joint. Is that clear? We have already discussed about the turning joint. So rotation happens between link 1 and 2. I can say link 1 is under rotation with respect to 2 or link 2 is rotating with respect to 1. Okay, so rotation happens between link 1 and 2. Either I can say 1 is rotating with respect to 2 or 2 is rotating with respect to 1. Like that I can mention here. Okay, I hope it is clear. Now coming to the next joint, sliding or the prismatic. Both the terms should be clear. Either sliding or prismatic, right? Diagram already we have seen. So this part will be sliding. The link 2 will be sliding with respect to the link 1. Link 2 in this particular case, this link 2 will be sliding with respect to link 1. Clear? Now next, cylindrical joint. What do you mean by cylindrical joint? Very important part. Rotation as well as sliding will happen. Rotation as well as sliding, both will happen. Okay, in cylindrical joint you should understand like this. both sliding, I will write instead of translation, both sliding and rotation. Clear? Both sliding and rotation will happen here. Both sliding and rotation. So this theta represents what? The rotation, and this S is representing what? The sliding motion. So that is what known as cylindrical, right? So if only rotation happens, turning. If only sliding is happening, sliding joint or the prismatic joint. If both are happening, cylindrical joint. If both are happening, cylindrical joint. Clear? And both the motions are completely independent in case of cylindrical joint. Please remember this point. Very important point, because there is one more example where rotation and sliding are dependent. Okay, please understand here. When I am writing both sliding and rotation, both are independent. So I will mention here, both sliding and rotation are independent. So what do you mean by this point? It means whatever the translation is there, it is not dependent on the rotation. I can have the completely independent translation as well as rotation. Both the motions are completely independent. The rotation has nothing to do with the translation part or the sliding part. In a similar way, sliding has nothing to do with the rotation part. Are you getting the point? So that's why I have written both sliding and rotation are independent in this particular cylindrical joint. Next, spherical joint. So in spherical joint, what will happen? Please understand. So rotation happens in all the three axes. So this is theta we have, this is gamma, this is phi. So rotation happens in all the three axes. Okay. Only rotation is happening in all the three axes. So that is what the spherical joint we have. Now next, screw joint. That is what very important. This is what the sliding and this is what the rotation. But in this particular case, sliding and translation are not independent. It is dependent. Based on what? The helix angle. Please understand, this is very important point. I will mention here. Sliding and rotation are dependent. Are dependent in case of screw pair. In case of screw pair or screw joint, I will write. Okay, you can write pair also, screw joint also, that is no issue. Is it clear? Sliding and rotation are dependent in case of screw joint. Is it clear, everyone? Sliding and rotation are dependent in case of screw joint. Now next. Okay, next part is what? This thing, we have to write it. Okay. Kinematic joint we have discussed, but in some textbooks you will find kinematic pair as well. Turning pair, revolute pair, hinge pair, pin pair, like that. Turning pair, sliding pair, okay, cylindrical pair, screw pair, spherical pair. So whatever the examples of a joint we have discussed, same can be called as kinematic pair as well. So don't be confused between kinematic joint and kinematic pair. Joint means it is a connection. Pair is also itself a connection. Na? When two links get connected, it will form a pair. So pair is itself a connection. It is itself a joint. So never ever confuse between kinematic joint and kinematic pair. Okay, I've seen many times students are saying, sir, in my book kinematic pair is written or somewhere else it is written kinematic joint. Okay, so don't be confused between kinematic pair and a kinematic joint. Very, very important part. So the part that we have discussed here, please understand one by one everything. So kinematic link, we have started with the kinematic link. This part is very important. Whenever these images are in front of you, please keep in mind there has to be what some part, okay, part of a machine will be there. For that we have drawn such kind of diagram, kinematic diagram we have drawn. Okay, so never ever just try to learn all those things without knowing actual thing behind that. So we learn all those things, we know this line diagrams, we have drawn these things, but we have never think about the actual part for which we are drawing this kinematic diagrams. So always keep in mind these diagrams, very, very important. Okay, so in this lecture what we have discussed, kinematic link we have discussed, which is the basic building block of mechanism. Whenever kinematic link get connected, when there is a connection, it is called a kinematic joint. But the very important point is there has to be what the relative motion. If there is no relative motion, then you cannot call it as a connection. Connection between the link is there. And second point is the relative motion should happen, right? So kinematic link, basic building block of a mechanism. Whenever kinematic links have a connection, it is called as a joint. Joint we have classified into three ways, based on number of links connected, based on the nature of surface of contact, third based on the relative motion. Total three classification we have done for kinematic joint. Whenever nature of contact is surface contact, it is called as lower pair. And whenever the nature of contact is what? Point contact or the line contact, it is called as higher pair. This lower pair, higher pair, you should remember it, please everyone. Lower pair or higher pair definition you should know. Lower pair is for the surface contact, higher pair is for the point or the line contacts. And for kinematic link, two important characteristics I've told you. It should be a resistant body and there should be a relative motion. Is that clear? So kinematic link, kinematic joint we have discussed completely. In the upcoming session, we will go into detail of the degree of freedom also. We'll discuss the mechanism. Okay, till now mechanism, basic definition we have discussed. Then we have talked about kinematic link, kinematic joint. Next we will calculate the degree of freedom of a mechanism also. But before that, there is one more topic that we have to discuss, is the constrained motions, types of constrained motion. That is also a very important topic here, right? So in the upcoming sessions we will discuss those part as well. Meanwhile, if you have not watched this lecture in a live, please make a note of all those lectures, all the notes that I am giving here. Please make a note. Okay, and if you have any doubts or any question you want to ask, please comment in the video itself. I will reply you as soon as possible. So whatever the doubts or any confusion or any doubts, any questions you are having with regards to theory of machine subject, please comment in the video. I will try to help you out. Okay, and in the last guys, please try to join, as I already suggest you, try to join this Telegram group channel, right? And the link for that one is this one. Okay, thank you so much. We'll meet you in the next upcoming session. Please stay tuned to the IMS GATE Academy YouTube channel, and please see the community section where you will get all the schedules. And also if you join the Telegram group, you will get all the notifications regarding the live lectures that we are conducting, right? Thank you so much. Bye-bye.